Hello everyone, this is a video presentation for Algorand Greenhouse Hack number 3, Learning Challenge, Box Storage with Beaker. For this challenge, I will present you a bet contract that I call the bet algos for fun, or BAF, B4F, if you will. First, I will explain why it's interesting for this contract to use boxes. Boxes have some advantages and some drawbacks. We'll see that later. But the advantages for this kind of applications is very important. First of all, we do not need to opt in a user to make a box. So users don't have to opt into our bet contract. They just need to place their bet and that's done. And also, we can create as many boxes as the app needs. If we have 2 bettors, 2 boxes. 10 more, 10 boxes more. There is no limit in that kind. Boxes can also have any internal structure. We will see that Beaker helps us for structuring data in boxes. They can be deleted, so their MBR is retrievable when we delete the app. And on-chain, only the app can read from the boxes. Off-chain, of course, everyone can read anything from anywhere. However, what are the drawbacks for boxes? Okay, we have to ensure the box name is unique. In our use case, since the key of the box is the address of the bettor, there will be no problem. It's unique. Then, if the app is deleted, you have to delete before deleting the app the boxes. If not, you cannot retrieve their MBR. And of course, if you want to access a box in a transaction, you have to add the box in the boxes parameter of the transaction. Okay, so now we will see what the bet contract look like. Okay, the bet contract was made with Beaker. So here simply all the imports that I needed. App creator, the creator of the address, and here begins the application with a structure that is a name tubed, that is a Beaker structure that holds a result and an amount as 2uints64. This will be held in a box. This structure helps us to retrieve result and amount without having to take bits in the box. The bet application itself, so some global values, an oracle, this is an account that can set the final bet result. Latest bettor, bettors count, that is useful when deleting the app. We will always check that bettors count is 0, since we increment bettors when they place a bet. We decrement bettors when they claim a bet, whether it's winning or losing. There is also a function that delete all losing bettors automatically if the app creator wants to claim early their earnings. Okay, here we have the result, the final result of the bet. Taken well, as a choice, I made 0 the yet to be announced. So if it's 0, the bet cannot be claimed. 1 is for result 0 in the array of results, 2, etc. The bet end, which is timestamp that ensures that before the bet has ended, we cannot claim anything. A bet description, and here we compute the minimum balance required by a box. The equation is fairly simple. We have first a box flat fee minimum balance, which is 2,500. A box byte minimum balance, which is 400. A flat fee that I added for the creator, which is flat in the sense that it's a one-time fee when anyone places a bet of 0.1 algo. This can be removed, and the minimum balance is operated like that. It's a box flat fee plus the better record size. In this case, since we have 2 in 64, this will be 2 times 8, 16. The better record box size. Since the better record key size, we will see it in a moment, is an address. It's 32 bytes. Times the box byte minimum balance. We have seen it here. The result will be this number that we have here. Allez. Not too cheap, but it can be recovered later when the box is deleted. So, some possible bad results in an array of max key 8. It's a choice. We can have add a box for that, but I decided it was a little bit complicated. So better to have a box for users and simply a max of 8 possible keys for results. This can be changed for by a box, obviously. Okay, here we store the total amounts for each possible bet. Here the total amount that is betted, the total earnings for the creator, and here we have finally our boxes. In order to make a box with Beaker, we have to make a mapping. This is fairly different from Solidity mappings, since this is per user, since we map an address to a better record. Okay, a better record holds a result and an amount. For example, if address A can bet for result number 2 10 algos, we'll have address A mapped to the bet record that has 2 values. Creation of the application, which is simply initializing all the global variables, application state. When we start a bet, we have to give a description, a result, a bet length, which will be added to the global timestamp, so in seconds. An oracle, that is the only account that would be that would be capable of setting the final result of the bet when the bet has already ended. So all this code is fairly standard. Here we have a simple for loop that sets the results in the reserved array that we have seen later. The amounts are set to 0 initially, and the possible bet results to some kind of string encoded in bytes here. This function set the result for the bet. It's authorized only for the oracle. And of course, it checks that the bet has finished. The initial result must be 0, so we avoid a reentrancy. And the result that is set is in the array of possible results. Okay, when we place a bet, here we will use our boxes. So some assets to check if the sender is correct. This is not too important. If you want to read it, go ahead. The part that is important is here. Okay, in order to use our better record, first we will set some variable output to the result and the amount. The amount is simply taken from a payment transaction inside the place bet. The payment is here, and the output is a class is a of type of the class better record with a mapped tuple. So first we set the output, and the better records better payment sender, which is the address of the sender, is set to this output. As simply as that, we have created the box, and the box is created for this user. We update the other value, the amount, the total amount, etc. Okay, so that is for the first bet. As you can see, I don't show it, I've not shown it yet. What we have the amount that we give our user is not directly the first payment. If you know where is it? Um, okay, it's there. The amount is set to the amount we have received from the payment minus the flat fee for the creator. This only occurs when you place your first bet. When you increase the bet, no more fees. It just updates the storage, the box storage here. Before that, we have ensured, of course, that the storage box, so the better records payment center, which is an address, exists before we can do anything. A simple internet transaction to pay someone. We get the earnings. Okay, it's nice to see how much we earn yet. And here we claim the bet. Okay, for when we are claiming the bet, an important part is that we have to set the minimum fee to 2 times the normal value, since when we claim the bet, the contract will use this function, which is a pay function, and somebody has to pay for this fee. It will not be the contract. It's not a good idea to fund the contract that way, because it can lead to some people trying to drain the contract and to make it unusable because I don't know, they lose the bet, so they they are not happy. So when we claim the bet, we operate here the better result, which is simply proportional from the total bet inside a valid result, and it transfer it to the better. If not, it just deletes the record and sends them nothing. So the box is deleted anyway, whether there is a payment or not. So this function will remove a better that has claimed his bet, is paid if he wins. If not, just the box is gone and we can retrieve it in BR. Here we are simple functions that get a bet for a user, and we have a function that removes all bets. If this function is here in case the app creator wants to enforce or remove losing bets. Let's say all the losers don't use the claim bet function, so somebody has to pay this transaction. This is only one transaction, nothing more, to remove all losing bettors. Winning bettors, of course, will want to retrieve their earnings. Here's some a function to pay creator when the app is deleted. When the app is deleted, okay, it can only be deleted if the bettors count is equal to zero. This means that all the boxes have been deleted before calling the delete application. Okay, so if it's true, we pay the creator and we approve the delete function. This delete function can only be called by the creator since we send the transaction for the receiver creator and with the remaining to the creator. Anyone that calls this function except the creator will end in a rejection. Okay, so that's a fairly simple contract, but with full of functionality and using interestingly in an interesting way boxes um, via the function of Beaker that is mapping, in this case, a map an address to a better record. Okay, so how do I tested these functions? I made two scripts, deploy in sandbox and deploy on testnet. Okay, in the README, you have all the details to use it. I will use here deploy on the testnet in order to explain how it works. The two scripts work similarly. Okay, if you choose to deploy to the testnet, don't forget that it's important to here we have a template for our environment to make your own .env based on this template example. You have to fill your pure stake token. You have to have five addresses and five mnemonics. It's fairly easy to generate that. For example, here I have a generate account function that generate accounts for me. It's really it's not complicated. Okay, I will use now testnet. To deploy, simply run deploy testnet. It's the only thing. We'll run it. Okay, first it ensures that all the addresses are founded with at least 10 algos. Then it will create our application. This should be not too long. Okay, our application is created. We will take this number and simply go to our testnet explorer, and we will see if the application is truly there. And yes, we have our application at this URL, and this is the creator of the application. Okay, right now it's not deleted. Okay, we have some approval program. Okay, and some application state. You see better description, which is there. Not too not too easy to read. Okay, we have some bet end, etc. Going back to our terminal to see what happened there. In the terminal, we'll see that we have created the app. A bet was placed for this particular address. For I think it's 1 algo. Yes, I put it 1 algo, and we have in the application returned a box for this address. Result 1 algo minus the fee, 0.9 algos. Okay, the same for a second bet that is tried to be placed as the same and fails. So it's okay that fail. We cannot re-entry in the place bet function. We have to use another one that is the second one, increment a bet. Okay, and increment a bet functions as expected. 1 algo more, and here we don't have a minus fee. The fee is only for the first bet placed. Okay, we check the accounts bet, and the amounts are correct. We get the bet status, and the description is test bet for match team A versus team B. Results are 1x2, etc. Some function to wait for the bet to end, and the accounts try to claim the bet. Okay, here I've put some tested. I've put some test to cannot set a result if the bet has not ended. If the bet ended, we cannot another account that is not a creator cannot set the result. And in the end, yes, the bet has have been set um, uh, for a result of 1. I believe yes, bet result set to from Oracle, which is the app creator, and in this case to 1. Users claim their bet. Okay, they claim their bet with the operation. So the account, in my case, account 1 wins, account 2 loses, and account 3 wins also. So we have two amounts. Here we can see that they get their earnings correctly with only 0.002 transaction fee, which is double the amount of a normal transaction. And in the end, we see how the application closes. It's fairly easy to see. The benefit was exactly 0.3 algos minus, of course, the 0.02 algos that we have to pay to the network for the transaction to claim or to not to claim but to close the application once we have called delete using delete the losing bet users. So I really encourage you to go to the script and read it, modify it, try to work with it. It's really interesting to get to know how to work with the contract and to understand well how our boxes function. There are some things that are not as easy as it seems. I've tried to document it in the README file. Similarly, the sandbox works exactly equal. In this case, I've used the Algo kit, so it's very easy to reproduce. And I've put some documentation if something went wrong or how do you see your transaction. To end this presentation, I will go back to the Algo Explorer for the testnet, and we will see if everything has been done. The last thing the application does, in this case this application with application number, is to close the application. So if we will see if the application have been closed or deleted. I will reload the web page. Okay, so we see we have our application on the block, and we see the deleted has been asked to true, and the last transaction should be a transaction for an app call, and it will be closing the account with a transfer, okay, to the app creator of the pointry fees that remains uh, in the application. Of course, we have retrieved all the boxes in BR since we have deleted all the boxes before deleting the application. Thank you, Algorand, for this hackathon. I hope you liked the application, and feel free to contact me through GitHub. I will leave in the comments the GitHub page and the Bounty description in Gitcoin. Thank you everyone, and see you soon.